Hey guys, Dr. Betts coming with another fantastic chemistry video, and today we're going to do scientific measurements in your laboratory manual. Today we'll be learning how to measure properly using analog and digital devices. It's easy, it's fun, and you're going to learn a little bit about how to measure, okay guys? Now I know you guys are thinking that, hey, I know how to measure, I can read things off a scale, but I'm going to show you the scientific way to measure, to squeeze every bit of precision out of a measuring device that we possibly can. All right, guys, today we're going to measure density, we're going to measure the length of a line, we're going to do density of a regular shaped object using what's called volume by displacement. It's going to be really cool, it's going to be really epic, guys. I'm looking forward to showing you how to do it and getting these experiments done for you guys. All right, guys, without any further ado, let's get after it, let's get it done. Okay, class, here we go. This is part one of the scientific measurements experiments. Measuring distance, here we have our centimeter ruler. So here it is in centimeters right here. And here is the measurement. Now I'm not going to read it to you. You have to read it yourself correctly off this device. Put it in your data sheet with using the proper number of significant figures and the right number of units. So let me zoom in here so you can read that line maybe a little better. There you go. Now remember, you have to use the estimated digit in all analog devices. So that's part one. All right, class, now we're on to part two, volume of liquids. First, we're going to do the graduated cylinder table in your data sheet, and then we'll move on to the test tube data later on in this video. So right now, we're working on part two, volume of liquids, graduated cylinder data. Now, here we have our three graduated cylinders. Let's fill out the table, shall we? Now, again, I am not going to tell you what to put in the table. You're going to have to figure that out for yourself, but I am going to zoom in on the meniscus of the liquid, and I'm also going to zoom in on the sizes of the containers. You're going to have to figure out what goes where. Don't forget to use the units and the appropriate number of significant figures. Okay, class, we're setting up to do part number two, test tube data. Here I have the burette set up. I've got it filled to the top. I'm going to show you the meniscus here in a minute. Again, you're going to have to write down the initial and the final volumes that I'm going to show you. For all measurements, you have to write down the measurements. I'm not going to do the measurements for you, but I am going to do the procedure. I am your lab partner. I'm going to do the procedure. You're the scientist. You're going to do the data. Everything's going to work out fine. So here's the burette filled with water that's got green food coloring in it. Normally we wouldn't use the food coloring, but the food coloring stands out better on the camera. All right, so let's zoom in. Let's get that meniscus for the initial volume. All right, class, now we're going to fill this test tube with water. And the next volume you see, the next meniscus you see, will be the final volume. I'm going to fill this test tube to the top, and then we're going to take this material and transfer it to a 25 milliliter graduated cylinder. There we go. So there is the test tube filled to the top. All right, class, now I'm going to pour the entire contents of this test tube into this graduated cylinder. This is a 50 mil graduated cylinder. I know that your book says to use a 25. That's okay. I don't happen to have a 25 milliliter graduated on me at the moment, but I promise you the 50 milliliter graduated will measure exactly the same way. So Let's pour the contents into the grad cylinder. And look at that last little drop. There we go. And there we go. So now the next thing you see will be the meniscus of this device. Don't forget to read it to the proper number of significant figures. Also, don't forget to use the proper units. Now the book tells us we should do the burette readings again so we can have a more accurate reading for the next step. What we're going to do is we're going to fill the same test tube with water again from the burette. I filled it back up to 0. You saw the meniscus there. And now I'm going to fill this test tube up with water. Same way we did before using the burette. And instead of pouring this water into a graduated cylinder, I'm going to pour this water into a 50 milliliter beaker that I have right here. I'll show you the meniscus of both in a moment. There we go. And now pour this water into the beaker. There we go. Part 3, measuring volume of solid objects. Now we're going to do the direct measurement of a uniformly shaped object. So here we have a rectangular object that has length, width, and height. So this will be the length. This could be the width right here, and the height could be right on the side. Now the width and the height, I think we will agree the width and the height look about the same. So let's measure the length, shall we? There we go. That's about 0. And there you go. There's the measurement. Now remember, I'm not going to write these things down for you. You're going to have to read it off yourself. All the measurements in this class, the student must read. Let me see if I can zoom in for you on the measurement so you can get a little better view. There you go. So I think that's pretty easy to read right now. So write down that measurement. Don't forget the unit. Don't forget the estimated digit. Let's push it around this way now. Let's see if we can't get the width. So this would be the width. I think that's fairly simple to read right now. And we'll just flip it over to get the height. A little bit more. There we go. And there's the height. Go ahead and read these measurements off yourself. Write them in the data sheet in your workbook and calculate the volume. Remember, volume is length times width times height. Don't forget to put the right unit down. You're multiplying centimeters by centimeters by centimeters, so the correct unit should be, I'll let you figure that one out, guys. All right, so that's the end of the part 3 direct measurement. Now we're going to move on to volume by displacement method for determining volume. See you soon. Now we're going to do volume by displacement. Here we have, in the graduated cylinder, we have some water. You'll have to measure the volume. I'll show you the meniscus in a moment here in the video. I'm going to take this string, put it around this cup hook on this object. I'm going to submerge the entire object into the water. The water level at that point should rise up, and the difference in the volume levels should be the volume of the object. It's much like when you take a bath at home. When you fill up the tub, you don't fill it right to the top. Why not? Well, because when you get in the tub, your volume is going to displace the volume of water. You've noticed, when you get into a bathtub, the water level significantly rises because you have volume, just like this object here. So let's do the experiment. Let me put the string around the cup hook. Take the object, place it into the water. Now watch the water level. Again, I'll show you the meniscus later so you can do your measurements. See how that water level significantly increased. Let me do it again, see? Watch the level decrease. Now watch it increase. There you go. That's volume by displacement. Now we're going to do part 4, measuring mass. This is a digital balance, very nice balance actually. I'm going to put on top of the tray this little device called a weighing boat. Now I don't care about the mass of this boat. The mass of this boat is irrelevant to me. So I'm going to zero it out using the re-zero button, and the computer inside the scale will just subtract out the mass of this tray. What I care about, however, are the mass of these pennies. That's what I care about. So I'm going to put the pennies in the tray on top of the scale. It's just to kind of help protect the scale from any kind of harm that might come to it. The scale is very expensive, so we always try to protect it. So here I go, putting the weighing boat on the scale, putting the cover back on the scale, and just going to hit re-zero. So now the scale will just ignore the fact that there's something on top of it already. All right, now I'm going to read out the year of the penny. You're going to want to write down the year and the mass in your data sheet. This penny is 1993. Let me put the cover back on. And there's your mass. Let's re-zero it. This penny is 1974. This penny is 1989. This penny is 1980. Make sure you write down all the numbers, guys. Don't neglect them. They're all important. The next one that's coming is 1982. Oh, wait, no, sorry. It's 1988. One second. I can't read this penny very well. Yeah, 88. 88. There we go. Make sure you write down all the digits from the scales, guys. Don't neglect any of the digits. They're all important. Make sure that's okay. This one is 60, 1960. The next one is 2017. And it re-zeroed, that's good. The next one is, oops, I didn't read the year off that one, sorry. Let me grab that one. Let me grab that year for you real quick. This is 1982. 1982. And zeroed, good. So this is 1997. And there you go. There's the mass of the last penny. All right, so that's how you use a digital scale to mass out some pennies. Now you're going to have to use this data to make a graph using the graph paper in the back of your lab manual. All right, guys, and that is the end of experiment 1. I want to wish you all good luck and good chemistry. See you soon.